Welcome to Prasun Ghosh Excellent Physics channel. Today's topic on gravitation. I am discussing different topics of gravitation. This part is very important. First, I come to the topic that is variation of acceleration due to altitude. Let a particle of mass m that is placed at height h from the earth's surface. Let a particle of mass m is placed at height h from earth's surface. This is the r is the radius of the earth. So the acceleration due to gravity surface, we have to write that is g equal to gm by r square. This is g dash. So we can write that is g dash equal to gm by r plus h the whole square. This is equation number 2 because at this is r and this is h. So entire distance from O to P, that is r plus h. So this is equation number 2. So dividing 2 by 1 we get that is g dash by g equal to, we can write in this format. So g dash by g equal to, we can write that is r square by r plus h the whole square. So g dash by g equal to r by r plus h the whole square. So g dash by g we can write that is in this format 1 by 1 plus h by r the whole square. So we have to write in this format. Using binomial theorem we can write that is g dash equal to g 1 minus 2h by r. So in this equation we observe that with increasing h, that is g dash decreases. So with increasing height the acceleration due to gravity decreases. So this is the variation of acceleration due to altitude. Next I come to the topic that is the relation between capital G and small g. This is the gravitational constant and this is acceleration due to gravity. So mass of the earth, that is m, radius of the earth, that is r, average density of earth, that is rho, acceleration due to gravity at the earth's surface, that is g. So we can write that is g equal to gm by r square. So we write, but we know that is m equal to 4/3 pi r cube into rho. Putting this value in this equation we get that is g equal to small g equal to capital G 4/3 pi r rho. So we get that is rho equal to 3g by 4 pi rg. So this is the relation between capital G and small g. We have to remember this relation. This is very important. Calculation of that is value of rho. So this is the equation of rho. Putting the value of g, r and capital G, we get that is rho equal to 5.5 gram per semi-cube. Hence average density of earth, that is 5.5 gram per semi-cube nearly. Prove that the weight of particle at the center of earth is 0. Particle, here is the particle, that is mass m, is placed at point P. This is the earth's surface and the distance from earth's surface, that is x. So total distance here, this is the radius of earth. So OP, distance of OP, that is r minus x. So let a particle of mass m is placed at point P from the surface of earth having radius r and mass m. We know that is m equal to 4/4 pi r cube into rho. Rho is the average density of earth. Acceleration due to gravity, that is at earth's surface, that is g. So g equal to gm by r square. So putting the value of m we get that is g equal to g into 4/3 pi r cube into rho. So we can write that is g equal to small g equal to capital G 4/3 pi r rho. This is equation number 1. In this case particle is placed. So distance from earth, that is x. So distance from OP, that is r minus x. So acceleration due to gravity at the depth x, this is the depth x, we write that is g dash equal to g 4/3 pi r minus x, this is r minus x that cube into rho, by this is the distance r minus x square. So we can write that is g dash equal to g 4/3 pi r minus x into rho. This is equation number 2. So dividing 2 by 1 we get that is g dash by g. So g dash by g we can write that is cancel that is g and 4/3 pi and rho, we get that dash by g equal to 1 minus x by r. So g dash by g we can write 1 minus x by r. So g dash equal to g 1 minus x by r. So hence with increasing depth, the acceleration due to gravity decreases. So increasing x, so acceleration due to gravity decreases. So you can write, so at the center means, this x becomes r, so x equal to r. So we get that is x, putting the value x equal to r, that is g dash equal to g 1 minus r by r. So g dash equal to 0. So g dash equal to 0. So weight is 0. Hence the weight of the particle at the center of earth is 0. So this is very important numericals. So acceleration due to gravity decreases by 1% at height h. Above earth's surface, the acceleration due to gravity at the depth h. Below the earth's surface, there are 4 options. So decrease by 0.5%, decrease by 1%, increase by 0.5%, decrease by 1%. So we know that is g dash equal to g 1 minus 2h by r. This is the acceleration due to altitude. So here we get in this format. So from this equation we can write that is g minus g dash by g equal to 2h by r. So this is we have taken, this is x, this is the x. Again in case of depth we write that is, we can write that is g dash equal to g 1 minus h by r. So similarly we can write that is g minus g dash by g equal to h by r. So this is y. So comparing 1 and 2 we get that is x equal to 2y. So from this equation we get that is x equal to 2y. So y equal to, we can write that x by 2. So acceleration, so y equal to x by 2, hence acceleration decreased by 0.5%, that is 0.5%. So this is the numerical relating to the acceleration due to gravity. There is one numericals relating to gravitation, that is satellite. A satellite is revolving round the earth. To make it escape from the gravitational field of earth, its orbital speed must be increased by number A, that is 50%, number B 41.4%, number C 100%, number D 73.2%. So orbital velocity, that is v0 equal to root over gr, escape velocity, that is v equal to root over 2gr. So this is the so this part is higher than v0, so ve greater than v0. So we can write that is ve minus v0 by v0 into 100%. Putting the value in this equation we get that is root gr by root gr into root 2 minus 1 into 100%. So we get that is 41.4%. Hence answer will be 41.4%. The answer will be option B. Another numericals relating to, that is the escape velocity. So escape velocity from the Earth's surface, that is VE. A body is projected with velocity 3v. In interplanetary space, it will move with the constant velocity equal to, there are four options, that is root 2v, option B 2v, option C 2 root 2v, option D root 3v. So देखे ना, so let the velocity of the body, that is v. From the conservation of energy we can write, so that is half m v square minus g mm by r. So this is the total energy. This is converted to half mv square. So this is m cancelled. So we can write that is 9v square by 2 minus gm by r equal to v square by 2. We know that is ve equal to 2gm by r. Putting the value, that is gm, from this equation we get that is 9v square by 2 minus half v square equal to v square by 2. So from this equation we get that is v equal to, that is 8v square. So v equal to root 8 into ve. So ve equal to root 8 into v. So we can write that is v equal to 2 root 2 into v. So we get this option number C. So answer will be, that is option number C, that is 2 root 2 into v. Today's class is now ended up. Please like, share and subscribe to my channel, and please comment in the comment section. Thank you all my dear students. Thank you all my dear friends.